Alright, so these were the basic and the most standard of the integral formulas. That's not the end of it though. There are some more formulas which will be coming up. But before that, and in fact for those formulas, we need to learn a certain technique of integration. It is one of the most important techniques, and it is a technique which is used widely in all integration problems. And this method is called the integration by substitution. So as we have seen, in differentiation you can differentiate virtually any function that is given to you. However, the same is not true of integration, because there are only certain forms of functions, certain types of functions which can be integrated successfully. And therefore, we need to find out certain techniques which will simplify the integration for us. So most of the integration techniques are aimed towards simplifying complex functions which are too hard to integrate directly. So therefore, what we do is we try to make certain substitutions of those functions in terms of other variables, so that the resulting substitution and the resulting function because of the substitution becomes much simpler compared to the original function, which then can be integrated, and then the values of the substitution can be put back or plugged back in terms of the original variable. Okay, so that was a little bit abstract. Let me explain myself through this example. Suppose I want to integrate tan inverse x by 1 plus x square with respect to x. Now this is a function in which tan inverse x is an inverse trigonometric function. It's in the numerator, and in the denominator you have 1 plus x square, which is a polynomial function. Well, if you want to differentiate tan inverse x by 1 plus x square, it will be very easy using the quotient rule. However, there is no equivalent of quotient rule in integration, and therefore you cannot present a rule for the integration of a function of the type u upon v. However, if you have a function such as tan inverse x and that is divided by 1 plus x square, and by remembering that the derivative of tan inverse x is the function 1 upon 1 plus x square, we can simplify this integration. How? By substituting another variable, say t, as tan inverse x. If I differentiate this equation with respect to x, I get dt by dx is equal to the derivative of tan inverse x, which is 1 by 1 plus x square. Now dt by dx is the derivative of t with respect to x. However, it can also be considered as a fraction. So here the dt is the numerator and dx is the denominator. So you can write dt as 1 upon 1 plus x square dx. And so if you observe, the function to be integrated also contains dx upon 1 plus x square. The rest of it is tan inverse x. And so therefore, if we make this substitution onto the original function, we'll get t dx by 1 plus x square, which is dt. So this equals integration of tan t to the power 1. So that's t square divided by 2 plus c. But what's t? T is tan inverse x. And so you get tan inverse x squared by 2 plus c. So this is the value of integration of tan inverse x by 1 plus x square with respect to x. And so in general, if we have a function of the type f of u times f dash of u du, you can always make the substitution t is equal to f of u and then dt becomes f dash u du, and then you make the substitution and you simplify the integration with this. Is there a general rule for making substitutions? Again, no. The process of substitution and solving the integration using substitution is also a certain process which requires a subjective amount of judgment, and there is a little bit of trial and error involved. But then that is the fun of integration. There are no set rules as far as substitution is concerned. However, if you successfully simplify an integral making a certain substitution, then you can always solve the integration. And many times for many questions there are more than one ways to integrate a particular function, unlike in differentiation. And so therefore that is what makes integration fun, but sometimes a little bit daunting as well.